Dear students, in this session, we are going to see different models of the artificial neural networks. So we are going to learn about the basic models of artificial neural networks. The basic models can be categorized according to their interconnections, learning rules, and activation functions. Okay, so what are the different types? We will see. So according to the interconnections, how the neural networks are connected. One is feed forward, feed backward, and recurrent. In the feed forward, again, you have the single layer and multiple layer. And in the recurrent also, you have the single layer and multi-layer. So we'll see the interconnections based types of networks. If you say single layer feed forward network. So what is meant by feed forward? So this is very most important point. So 1 second before telling about this, I want to Oh, okay. So what is feed forward? So we are telling that all the nodes are connected. Okay. So if I'm taking 1, 2, 3. Okay. So you'll have input over here. Here one input. Here in input. If I take x1, okay, you can take anyway x3. For this one, you'll have the w1. Here you'll have the w2. You'll have the w3. Okay. So these will be combined with the help of summation over here, and you will have the threshold. You will get the output. Okay. So what exactly we are doing over here? So I'll calculate x1 into w1 plus x2 into w3 plus x2 into w2. You'll get some value that is called as I. I'll check whether it is less than or equal to threshold. If it is equal to, I'll go with. Otherwise, I'll stop here. Okay. So you don't have a chance here. Whenever you're not getting the required threshold, you don't have a go back again for changing the weights. Okay. Again, what I have to do? Again, I have to reconstruct the whole network and I have to do this. So moving only in the forward direction. See here, you're only moving in the forward direction. Suppose if I want to change that, what I'll do? I have only single layer here over. So these are your inputs. I'll only forward these particular weights into the next layer with the different updated weights. Okay, but I cannot move backward. So this type of networks are called as feed forward networks. Got it? So this is example for single layer. So that's why I didn't told this one. So single layer feed forward network. Okay. So if you want to go for the backward, again, you have to go with a different network. So if you see here, what we have done? We'll have the x1, x2, x3, so on required weight. So this is x11 for 1, 1. If you take x21, so wait for 2, 1. If I take x22, this is for 2, 2. X22. Okay. So these are the weights and you'll get the output and you'll check the threshold value and you'll get the output. So this is single layer. If you see here, only one layer of neurons are there and it is only feed forward. We don't have any link for the backward. Now, so same thing. It will be have the output vectors O1 to OM and X is the input vectors X1 to XN and Wij is the connects with the ith neuron with the jth input. So you will calculate the net I with the help of this formula. Wij into Xj you will get for 1 to I equal to 1 to M and you will get the output of the summation complete value and these are the weight vector. Okay. So this was only single layer, only one layer of nodes are there, neurons. Coming to the second one, multi-layered feed forward. Here also, you'll have the two layers, layer 1, layer 2, and hidden layer may be n number of layers. Here you may have 10 layers or 2 layers or 5 layers, 100 layers. So these are your inputs. And this hidden layer, if you're not getting the required output with the first layer, it will start another new layer. Another new layer. So that like that, it will be added. Okay, it will be added multiple hidden layers over here. So you may have 3 hidden layers. Okay, You may have 3 hidden layers or 4 hidden layers or 100 hidden layers, but this will be continued unless it is not satisfying your threshold value. So this is multi-layer feed-forward network. Next one is your lateral feedback network. So processing back as input. See here. Here you'll have the feedback. As I said, you'll have the feedback. So if this output is not appropriate, if you feel it is not correct, again you'll feedback to the previous layer. So this is a lateral feedback network. So in the feed forward, you don't have. But here remember, it will be in the same layer, not in another layer. So if it is in the same layer, it is called as lateral feedback network. Okay, next one is recurrent networks. So what are the recurrent networks? These are in the closed loop. If you see here, within this particular loop itself, it will be work. See, if you go here, again update, it is not working. Again, I'll come here, again update, again come here. So it is a closed loop. So these recurrent networks will have the closed loops and the response will be at the k plus 1 instant. Okay, when k equal to 0, because in the first instance, you don't get the output and you have to check for the multiple times within the loop. And it will have the discrete time inputs and discrete data representation, which is called as automaton. Now, what are the different recurrent networks? Single node with own feedback, competitive net, single layer recurrent networks, multi-layer recurrent networks. So single node with own feedback means within the same loop, you'll have the feedback. Single layer recurrent networks will have only one layer with the recurrent property, like you can feedback the data. Multi-layer, you'll have the multiple type of layers. Those are hidden layers. Now, single layer recurrent networks. If you see here, these are recurrent. So same layer, you are changing the input. So you will check it is not optimal. Again, I'll go there, single layer. So it will be in the same layer. Next. So how we are going to do learning? Okay, this is related to your recurrent networks. Now coming to the learning, there are two types of learning. One is parameter learning and structured learning. In the parameter learning, connection weights are updated. In the structured learning, the complete network structure has been changed. So only weights are updated means it is a parameter learning. If the structure of your network is changed, it is called a structured learning. So coming to the training, in the training, you'll have three types of things: supervised, unsupervised, and reinforcement. See, there is a difference between learning and training. So you are making this particular network in order to get according to threshold, that is learning. And you are making that particular complete network to be trained. So that is called as trained in order to get the required output. So there are three types of learnings: supervised, unsupervised, and reinforcement. So these will be classified according to the learning rule. First one was according to their connections. Second one is according to their learning. So you have the supervised learning. In the supervised learning, it is like your teacher. Okay. So you'll have one teacher and you'll have the target output. So you'll have the input vector and required or target vector. So you will train the network according to this particular target vector. You'll have some reference. So you'll have X. So your network it is there and you will generate the summation. And if this is not actual output, again, I'll go for the signal generator. Again, it will be changed. Okay. So neural network, if it is not actual output, I'll go for the error part. It will again change the weight or it may change the complete structure. So this is called as supervised output. This will be done unless until you are getting the desired output. So yes. So if you see here, you'll have the adaptive network. Okay, you will get the output. If it is not exactly, again, I'll go for the distant generator and again, it will go for the back. Again, it will generate. Again, it will. So you'll have the learning signal. So what type of learning we are going to use? This is supervised learning. Coming to the unsupervised learning. So unsupervised learning, you don't have any teacher. You don't know. So for example, how a fish or tadpole learns. So what it will do? It will group together as a clusters. So it will see the matching. Okay, so same type of tadpole is there, it will go to their group. So this cluster will be formed only with the similarity, not with the targeted output. So this type of learning is called unsupervised learning. So you don't have here, if you see here, don't have any learning signal or nothing. Whatever you are getting, that will be your output. And only the thing is, if you feel that the output is not correct, again, I'll have to send back. But you don't have any target you compare. Okay. So self-organized learning. So unsupervised, we don't have any feedback. Network must discover own patterns, regularities, etc. And while doing, the network might change the parameters. And this process of doing on their own is also called as self-organizing learning. So unsupervised is also known as self-organized learning. And the third category is reinforcement learning. So what we are doing in the reinforcement learning, will that the input, actual output and error signal, and this extra reinforcement signal will be there, which will be helpful to get easily the target output. Okay. So this error signal will be reinforcement signal, which you will input while giving your input like weight and nodes. Okay. Now, so what are the different types of activation functions? First one is your identity function. So in the identity function, you'll take as it is. Second one is binary step function. 1 if x is greater than theta, and this is your threshold value. 0 if x is less than theta. Binary step function, here it is 1, 0. Here it is 1 and minus 1. Okay. Next, sigmoid, you'll have the continuous functions. Ramp function is like this. 1 if x is greater than 1. X if x is lies between 0 and 1. 0 if x is less than 0. So these are some of the activation functions which you have to learn. And what are the different types of learnings? Types of algorithms in case of the learning strategy. Supervised, you have Adalin, Madalin, perceptron, backpropagation, multi-layer, radial basis function networks. Coming to the unsupervised, you'll have the competitive learning, coherent self-organizing maps, Hebbian learning, learning vector quantization. So all these things are there in your syllabus, so we'll cover very soon. So not an issue. And what are the basic terminologies in your neural networks? We'll have the weight. Already we have seen what is meant by weight. What is meant by bias? Okay, we have seen what is meant by threshold and what is meant by learning rate and momentum. So this we will see now. 1 second. Yeah. So what is a weight? So each neuron is connected with the other neuron with the help of the direct links, and these links will have the weight. So weight contains the information about the input signal, and it is represented in the form of the matrix, and this matrix is also called as connection matrix. Okay, if you see here, these are your weights. You have 1, 1, 1, 2, 1, 3. So this is related to for each and every weight according to n. Okay, so this is called as weight matrix. So if you see this particular diagram, x1, so this is for 1 for jth neuron. Okay, ij means I for jth neuron. Nj means n for jth neuron. And this is the bias. And when you calculate this particular summation, this is a formula I've seen, x0 w0j, x1 w1j, x2 w2j, so on, xnj. So this is your weights. So activation function, already we have seen what are the different types of activation functions: identity, single, binary, discrete, continuous, sigmoid. All these are activation functions. These can be linear or non-linear. These are very much important in order to generate a signal. Now, what is bias? What is the bias? We have the positive bias and negative bias. So this bias is used to increase the net input or decrease the net input. Suppose if I feel that my weight is overloaded and is having very high net signal, so I have to decrease. So I will share the negative bias. If I feel that my signal is very weak, so I have to go for the positive bias. So the values will be like 0 or 1 for the bias. Yes, if the relationship between input and output is given y equal to mx plus c will be the bias here. So what is the coefficient of this particular linear equation will be the bias. So threshold will have some threshold value. We'll decide according to the threshold value whether the output is up to the mark or not. In this example, 1 if it is greater than or equal to theta and less than minus 1 if less than theta. So theta is your threshold value which we have to define. So learning rate, the learning rate is defined by alpha. It is used to control the amount of weight between the each and adjustment, how much you have to change. So weight have to be doubled or weight have to be tripled or weight have to be changed to half or weight have to be changed to 0. So this is called as learning rate. Okay. So we have done with all the basic models depending upon your connections, learnings, okay, and what are the basic terminology used in your artificial neural networks. I'm ending here.